You may have heard of a Monte Carlo simulation and wondered, what is it used for? Basically, it is used to determine a distribution of outputs or results when there's uncertainty surrounding the inputs that are used to determine those results. Let's take a look at a simple example of building a house. Now, we know that we need materials in order to build the house, but we also know that there might be some uncertainty in the cost of these materials when you need to buy them. So one of the things that you could do is develop a probability distribution function on the cost of each one of these materials. If you run the iterations, the cost will be sampled from this probability distribution. So in this sample, we know that 7 has the highest probability of being selected, but if you run enough iterations, you should get values that fall along the entire distribution, or nearly the entire distribution. Since my YouTube channel deals with water resources engineering, I wanted to give an example of how do we use this in water resources engineering. For those of you all familiar with the channel, you'll notice that this is a reservoir operations model. And you have a main stem of a river here. The water flows from top to bottom. And you have some tributaries coming into the main stem. And what we want to do is look at the impacts on this uncertainty on the maximum pool elevation in this reservoir. So here we put inflow into the upstream end of the model. And we want to see what type of impacts we have on the reservoir itself, and the variable that we want to apply this uncertainty to is going to be the maximum release that we can get out of the dam. So if we run one iteration, then we'll get a maximum pool elevation based on whatever that maximum release is. If we run another iteration and the maximum release is smaller, then we know that we're going to have to store more water, and that's going to cause a rise in the pool elevation. If we run another iteration and the maximum release is larger than that first value, then we know that we don't have to store as much and we're going to get a lower maximum pool elevation. So we can develop a distribution of maximum release values. So if we look at the table on the left, we can see that for a maximum release value of 297 CFS, that has a non-exceedance of 1%, which means that only 1% of the time is the flow value of the maximum release value going to be 297 CFS or less. Or another way of thinking about it is that 99% of the time, it's going to be greater than 297 CFS. If we go to the other end of this table, we can see that for the 99% non-exceedance, we have a maximum release value of 13,276 CFS, which again means that 99% of the time, the maximum release value will be 13,276 CFS or less. We can also run multiple iterations and have our reservoir model sample from this distribution and then give us a distribution of results. In this case, the results are the maximum pool elevation. So you can see in our results that we have a non-exceedance, or for a non-exceedance value of 1%, the maximum pool elevation was 683. And that's our desired pool elevation. That's the pool elevation that we started the model at, or it's our initial pool elevation. And then 99% of the time, the maximum pool elevation was going to be 696.65 or less from our simulation. To help you better understand what's going on from iteration to iteration, I'm going to show the inflow hydrograph once again. And you can see that this inflow hydrograph has a peak inflow value of 10,500 CFS. And remember, we start the model at 683 feet, and that's our desired pool elevation. So if we're on this end of the distribution for maximum release, you can see that these values are going to be enough to pass the peak inflow, which means that we're able to hold our maximum pool elevation of, able to hold our desired pool elevation of 683 feet. However, as the values drop below 10,500 CFS, it means that we're going to need to store a portion of the water. And that's why you can see that as our percent not exceedance gets higher, then also our maximum pool elevation is going to increase. So hopefully you found this video to be helpful. If you did, please like the video and/or subscribe to the channel. And thanks for watching this one.